Okay, so last time we talked about um, the basics of C Sharp, right? We covered arrays and lists as well as the basics of C Sharp so that we could do that little short in-class quiz, oral quiz thing that we did, whatever you want to call it, review thing. Today we're going to continue with that. We're going to talk about loops. Now, in this playlist, there's like 3 or 4 videos on loops. We're not going to watch them all. We're just going to watch the one that goes over the kinds of loops, which are the do, while, for, and for each. Now, we talked a little bit about the for each last time, and we talked about them a little bit in web dev yesterday, I believe. But I just wanted to just refresh you on that, and then we'll talk about objects. I know we know everything we could ever want to know about objects, but it never hurts to refresh with a repetition. That's my secret sauce there. So we'll talk about that, and then we'll do another one of those little mini reviews, and then you'll come back and go to break, come back, and we'll talk about what we're doing for our project today. So without further ado, let's check out this explanatory video on loops and such.
Hi, so we just talked about if statements and branches in C Sharp. Next, we're going to talk about loops. We also got a chance to go over the using namespace classes, the methods, everything you need at the beginning of your program to write a C Sharp application.
Right, we were in the middle of doing if statements, and then I got freaked out by all of this. So we explained that. So Kendra had the hello world explained. So now I can explore that, and you could also spend some time with that at home. But we're moving forward to loops, using loops to repeat statements.
Right, so the most basic loop in C Sharp is while. So while is whenever this condition is true, just keep on repeating it. So once it executes the code block once, it'll go back up to the top of that while loop, verify if the condition is still true, and then execute again. And it can just do that forever if it always finds the condition to be true. So
I'm going to take that code. I'm going to take that code and I'm going to drop it into my main here. And it's kind of hard to figure out how you should think about a statement like this. Like, should I read it in English or in my native language? Sometimes I read it like, while it is the case that this is
counter
true.
Counter is less than 10.
While counter is less than 10, do some stuff.
Right.
And sometimes you'll see people say, while true, which is kind of weird. But true is always true forever. So that means while true is true, which is forever. So while true means forever, which is kind of not really intuitive.
So that's what we would have an infinite loop in that case.
Actually, let's try this one, and then we can try an infinite loop and see what while false does as well.
Oh, good point.
So let's do that. So I'm going to hit Control F5.
So here, okay.
So that's...
So printed this thing out 10 times.
So we started with counter, which is an integer. We learned about those. While it is the case that counter is less than 10, do some stuff.
So it has a write line.
Right,
and in this write line, we print out the counter variable.
Okay, and then look at that. Counter plus plus. That's interesting. We could have said counter equals counter plus 1, but we just said counter plus plus, which makes it faster. And we could also say counter minus minus if we were going down.
Right, so that's just incrementing counter by 1.
Exactly.
The plus plus operator.
Right. Now, if we said while true, I wonder if this will crash my computer.
Oh, so it just keeps going and going forever until your computer runs out of memory or your battery dies.
Or if you remember, we did our talk on integers. So this will go until it runs out of room.
Oh, that's true. Yeah, your integer could be the thing that actually crashes it.
Yeah. So in this case, we could go up to what would we say? 2 billion.
2 billion, yeah, or causes an exception.
And if I change that to a short, which we saw was a really small thing, while true means forever, but shorts aren't forever things, right? Shorts only go into the 30,000s. So when it hits 30,000, it'll probably just freak out.
Oh, yeah. Okay.
Yeah, isn't that interesting? Oh,
I like this experiment. Oh, that's right, because we were just talking about how once integers went over, it would just tick over sort of like an old odometer.
So that flipped over. Isn't that interesting? So we're actually going, and what do I do, though? How do I stop it?
Right? I think you just have to exit out of the program.
Yeah, so I can do two things. I can either close the program just like this, and hit close, or I can hit Control C, which breaks out of your program. So if you ever get in trouble, you can go and Control C. And another great way to get out of trouble is undo, right? So I messed my code up. I'm going to go ahead and undo back to where we were before. So that was interesting. I learned a few things right there, huh?
Right, so we talked about the incrementer. What's next?
Well, we said while it is the case, but we can also flip it, right? We can flip it so that we do something no matter what. And then we have the conditional, or the check, because inside the while is an if statement, isn't it? It's kind of it's a conditional. So we're saying do this while that, which is flipping it on its head a little bit, actually.
Right. So the condition isn't checked till the very end. So you will definitely execute the code at least once, and then the condition is checked.
Right. So if I do this one, the result is the same, but if I did something like 10,
ooh, yeah.
Right, so counter is going to start at 10. It'll always at least do the first.
And then it hit the condition and it stopped the loop.
And then it stopped because at that point counter was 11. So do and while are kind of friends. They're kind of, there's a while and there's a do while. So that's kind of interesting. And they produce the same output in this particular example, but that's something for you to watch for.
Cool. And now my personal favorite, the for loop.
This is, for some people, and I would say for myself as well, the hardest one to get your head around. But once you've got it, you're going to use it all day, every day.
Yes, it is definitely my preferred loop. Even our docs say it's the most commonly used loop in C#. So
bring that in.
Yeah.
Now, what do I read? We said, while it is the case that this is true, but there's a lot going on here. There's 3 different pieces.
So I think a good way to approach it is, you know how you had the counter declared as a variable outside of the loop when it was while?
I did.
For for loops, you declare that variable inside the for statement. So that's where we're saying int index equals 0.
Okay.
So that's sort of our counter variable.
Okay.
And so we're just saying to repeat this while index is less than 10. The next statement there is basically the condition.
Okay.
And you might also recall we were incrementing counter within the while block.
Right.
With for loops, we can actually increment it as part of the loop statement. So it's sort of easy to see all of that in one place, so I know exactly how many times I will repeat this loop under what conditions and what my counter variable is.
That's a great point. So you've got the initializer, your startup, your setup, your initial state. You've got the condition, and then you've got the iterator. That happens every single time, right?
Right.
And this can be confusing to remember, but if you're using Visual Studio, you can just type for, and if you hit tab, it'll go and snip it. It'll expand out and tell you kind of how to do that, which is kind of cool.
I need to use that more.
Isn't
Yeah,
that great?
definitely.
Yeah. When you're typing in Visual Studio, if you see a little box that is like, see, it says code snippet, tab twice to insert, and there's other iterators like for each, and then also ifs that we did before. Look at that. So if you get used to those, you can move a little bit faster and you can type a little bit less, which is fun.
Oh, yeah.
All right. Cool. So I think that's probably a good place to stop, and then we'll come back and we'll then combine branches and loops together.
Good morning. All right, so let's break it down and talk about a couple of different things. All right, thing number 1. Counter plus plus. You may recall I said last time counter equals counter plus 1 also would work, but if you have the option to use plus plus or minus minus, depending on what the case is, use plus plus or minus minus, right? Format strings, that was whenever they had the, they put something in curly braces and it replaced it, right? So like if you had a variable called my name and it was equal to Bob, you could just put my name and it would print out Bob. You wouldn't have to do the plus. You could just say hello, or it's nice to meet you, curly braces, Bob, right? If you didn't want to have to worry about escape characters or different things like that. What do we call it whenever they were showing, when they changed it to a short and it got into the 30,000s and then it switched to the negatives and then it hopped back to 0 again and went back up to 30 and it kept switching back and forth? What do we call that phenomenon when that happens in programming? What is that known as? maybe it was yesterday in the afternoon class. I feel like I talked about this recently in class, and I felt like it was in this class, but maybe it wasn't. It's called an overflow. Okay? Oh, no, it was when we were talking about Pac-Man, we were talking about kill screens. Was that you and I that were talking about that? Yeah, okay. Yeah. All right. So in Donkey Kong, the kill screen in Pac-Man isn't a true kill screen. It's just an unplayable level because there's it's related to the same thing, but the right half of the screen is all scrambled characters, and so the level's unplayable. So you die, right? In Donkey Kong, when it happens, on the kill screen level, you make it a couple of inches forward, and then Mario dies automatically because time expires, right? Because you only have like 4 seconds on the clock. And the reason is because that is the maximum amount of data that particular memory register can hold. And so when it gets to that point, it overflows. And anytime you have an overflow, it's going to cause an error. There's a guy on YouTube, you should get on and look sometime, that he plays Paper Mario on the Nintendo 64, and using an emulator, he messes with counter overflows. And so he does a thing where, like, there's a part where you have to bake a cake for exactly 60 seconds or something. You have to hit the button when 60 seconds exactly has expired. He sets it to where they bake the cake for like 800 years, and then hits it when it hits 60 seconds again, and it still gives him credit for it. Like in that kind of stuff. So those are called overflows. When we talk about exceptions next time, I'll say this again, but be careful to avoid overflows because, as you might guess, they can cause some really squirrely, unexpected behaviors. What is the syntax of a for loop? Let's step through it here real quick. So we have. So before we do that, let's talk about for each for just a quick second. So for each is the easier of the two, right? Because for each is used in a scenario where you have a list of things. You have a group or collection of items. And you say it was called names. You say for each name in names, print out, it's nice to meet you name, right? A for loop is a little more difficult because we have to construct it, right? So let's talk about what the syntax is. So we have the for keyword, right? And we have a set of parentheses. And we got our little curly braces. So what were the things inside of the parentheses? Does anybody remember what the very first thing was called? I equals 0, let's say. Does anybody remember what that's called? Yes, sir.
The initializer?
Very good, yeah. The initializer. Because it creates a variable and initializes its value, right? Now, what is the next part of it?
Condition?
Yeah, exactly, man, excellent. The condition, which is at what point will we cease looping, right? And then the final part, you might not get the word exactly, but if you don't know the word, just tell me what it does. What's the third part?
The increment?
That's what I would call it. They called it the iterator, which makes sense because it determines the next phase of the iteration, I guess. But yeah, the incrementer or decrementer is what I would refer to it as. So either of those, huh?
Just to break the loop, so it's not.
Yeah, it's the break essentially, or it's essentially. Okay, so awesome. One other thing. So while loops or infinite loops. Remember one of the 10 commandments of programming: thou shalt not create infinite loops. So make sure you don't do that unless you're doing it for demonstration purposes. Okay, so now let's hop ahead and let's talk about objects until we are sick of them. So if you would like, feel free to fire up Visual Studio. You don't have to, but if you want to follow along, I'll give you just a moment to get that fired up before we get started. Before we do, any questions, concerns, comments, thoughts, or ideas about anything?
Yes. So,
Yes, sir. What's up?
So for a for loop,
Yeah.
would you use it for, kind of like what they were using it for, would you use it for like solely incrementing stuff, or are there other use cases?
It's a very hard question to answer because do you remember in 120 when I talked about there were things that I was going to have trouble giving you examples of because they are simultaneously useless and incredibly useful? Do you know what I mean? Like their use cases are both very specific and very broad. Primarily, yeah, it's used for something like that. Trying to think of a situation where you would. Well, okay, here's kind of a squirrely example. I don't know for sure if this is how it works, but like Xbox achievements as an example are probably a similar. I would say some of them operate as if statements, and some of them probably operate as for loops. Does that make sense? Like maybe loop over the score until this particular. So like an arcade style game, right? It might not make sense to do an if statement. It might make more sense, depending on how your memory is managed, to do it as a for loop. So just like, the score keeps incrementing, or I don't know. I'm trying to think of an example off the top of my head. But yes, there are use cases, to answer your question, outside of just incrementing numbers. But I would say that is unquestionably their most common usage. I would say the for each loop is going to be the one you're going to use the most often, because it has, since you can use it to manipulate lists and data collections, it's more useful than a traditional for loop, which has a much narrower scope. Does that make sense?
Yeah, so essentially for like for loops, you're going to be like just use it for incrementing.
Yeah.
For each, use it for like lists or arrays.
Yeah, exactly. Because, so do you remember when we talked about yesterday in WebDev 2, we talked about how he was using that for each loop to apply all those settings to all the buttons on the calculator?
Yeah.
Remember that? It's that same kind of thing, because like rather than having to the benefit there is you're not having to write that same you're not having to add all that stuff to each one of those buttons individually. You're just grouping them together by class and running a for each loop on them. Yeah. Yep. All right. So let's move on and let's talk about objects and classes. Now, they will say this in the video, obviously, but just as a reminder, a class is like a blueprint for a house, and the object is like the house itself or any of the many houses that can be built from it. A class is a blueprint or a design for all of the objects that are instantiated from it and created or created from it, whichever way you want to say that. And also, objects have two main things. What are they? Does anybody remember? I ask this question a lot, but what are the two main things with objects? They have.
Classes.
No, they have. Okay, so if the object in question is a car, the car is red, right? And the car can drive. Okay, so objects have what is red? Red is a color, right? Which is a attribute. Very good. And driving is something it can do, which is a
Method or function.
it's a method, because a function is external from an object. Methods are what we call them when they are within an object. So they have attributes and methods, which is to say they have variables that are specific to them, and they have functions that are specific to them, which are known as methods, so attributes and methods. All right, let's check out this next video.
We're learning about C# 101. I think we've reached your favorite part.
We have object-oriented programming.
Nerds.
So this is the, yeah. So this is the time in your C# curriculum where you know you've made it. Now we get into the serious bits of C#. We're gonna go over inheritance, we're gonna go over objects. It's gonna be great.
Awesome, cool. So what I'm gonna do is I've got my Exploring Object-Oriented Programming documentation up, and I'm gonna, again, snap that off to one side. And we just finished our Fibonacci sequence. You could go and check that video if you want to. But I think we should just start from scratch. It's File, New, Project time right now, don't you think?
Let's do it, yeah.
Okay, so in Visual Studio, I'm gonna say File, New, Project, and we're gonna basically get rid of the previous one and start from scratch with another console app. So I'm gonna make a console app, and we'll call it My Bank, I don't know, My Super Bank, right? We're gonna make a new bank. And we'll hit create. And then it's going to ask us if we want to save our old project. I don't care about that old project. We're going to toss that. We're starting from scratch. And we're back at Hello World. And the only thing that's changed is that it's My Super Bank, which is awesome. So
Better
we're
than
back
other
to hello.
banks.
It's way better. Other banks suck. Our bank is the best bank. So what we want to do is think about object-oriented programming, right? And make a bank account. Now, what is object-oriented programming? What are objects and why are we orienting around them?
So objects are basically a way that all computer languages can learn how to learn how to mimic the real world. So in the real world, we organize a lot of information in various different ways. With object-oriented programming, we can say, hey, a person can have a name and an address and a hair color and that kind of thing. So people can have different properties, and it's just a way of grouping all information.
Right. I mean, we're orienting around objects. Like I can make a mouse object or a bank object, or and then when you talk about inheritance, we can have animals, and there are types of animals.
Yeah.
Right? And you can have a hierarchy, just like you have in reality.
Yeah, definitely.
So it's intended, I think, to be intuitive of some kind. So hopefully you won't find this too intimidating. Okay. So according to this tutorial, they want us to make a bank account. So then presumably we need a bank account, and it has certain requirements. What is this?
Right, so it
List
looks
of
like we need
requirements.
a 10-digit number that will uniquely identify the bank account. So this is one of the properties that will be in our bank account. It needs a string for the name or the name of its owners. It needs a balance. It needs to be able to accept deposits and withdrawals. So
Right.
these are, I guess, capabilities that it'll be able to have. So they're not like a single unit of data. It's actually like a function that
That's a
will be
good point.
attached to this.
These first three are really characteristics or properties,
Right.
and these seem like methods or things that it can do, verbs. And then what are these two? These are kind of like rules.
Yeah, so it looks like the initial balance must be positive. So I guess when we're creating that balance number, we need to make sure that it's above 0. And withdrawals cannot result in a negative balance, which makes a lot of sense. That would not be a good bank system.
And this is very typical of object orientation, right? There's going to be some properties, like things, cars have color and banks have balances. Then there are the stuff it can do. Cars can drive, banks can take deposits. And then there's rules that while you're doing those things, don't exceed this speed, don't crash the car. So we need to go and start thinking about our bank account type.
Yeah,
Okay.
so lots of things that sort of describe the behavior and the design of what this object will look like.
Now, so far, we've been putting everything in program.cs. I feel like bank account maybe should go in another file.
Yeah, let's make a bank account class.
Now, on the right-hand side of Visual Studio here, there are these little flyout tabs. And when you click on them, different things fly out, like I can go to GitHub or whatnot. And I'm going to click on Solution Explorer and push this little pin. And this is going to let me see the files inside of my program. I have one called program.cs. And in fact, I can open it up and see my main. So these aren't, that's actually not a file, is it? That's showing me the structure of my
Yeah, so it'll list out the classes that you have within that file as well as the methods in each of those classes.
So I'm going to right-click using the right mouse button and say Add. I could say New Item and get a whole list of item. Or I can say Add Class.
Let's do that one.
All right.
Add a
let's do
class.
Add Class. So I can say Add Bank Account. Now this might be scary, but this is just a list of all the great stuff that you can add in the future. But we're just going to say Add Bank Account. That seems like a fair thing to do. And you look, it went into another file, and it has the same namespace. That seems like that same bucket.
Right.
All right. So look at this. We could copy paste, or I could type in public, because it's available to the public, string number.
Yeah.
And number is only gettable. This is called a property. I can get numbers, but I can't, once it's been assigned, I can't set the number.
Right.
But I don't want to keep typing that. That's tedious. That's
Okay.
tedious. I'm going to do this. Remember how before we typed for each and hit tab? Check this out. Prop, tab, tab.
Ooh, a code snippet.
Code snippets, tab, tab.
Okay.
Owner, enter, enter. Prop, tab, tab. Decimal, tab, tab. Balance, enter, enter. Look at that.
Man.
That
Or you
great?
could type it the old-fashioned way, but
Oh, nonsense. I want the computer to do the work.
tab is your friend.
Tab is a great thing to remember. Anytime you're in Visual Studio, tabbing will probably get you something. And worst case scenario, it gets you white space.
Right.
Okay, and then let's grab these two functions,
Right.
and then maybe you can talk
So
about
these were
those.
sort of the actions that were listed out in the requirements. So it needed to accept deposits and make withdrawals as well. So instead of properties, these are going to be methods. Everything that you see in this class, these properties and these methods, all of these are members that are just one part of this class.
Right. And when we made them all public, that means that other applications and other classes within our application can look at those and talk to those.
Yeah.
If they were.
Before he says them, does anybody want to take a shot in the dark and try to remember what the other two are? There's public and there are two others. Do you remember what the other two are?
Private and static?
Yes, private, no static. Do you want to guess again on the second one? Totally fine if you don't remember because it's one you don't see terribly often. Protected is the other one. And protected is actually slightly beyond the scope. Honestly, it's probably a little beyond the scope of this class in general. So I don't know if we'll get much into it in this class, but public and private are the two that are most relevant to it. We don't dive into inheritance a whole lot in this section of C#, in this level of C#, but it has to do with inheritance. It has to do with public and private are exactly what they sound like. Protected is a little unique, that it's kind of like it's private to anything external to the class from which it is derived, which is super complicated. And anyway, so yeah, public, private, and then protected, which we don't need to worry about right now.
Private, they would basically be secret, just to bank account, and no one else would know about them.
So right now your class doesn't have public in front of it, and we could also change that accessibility level.
That's a very good point. And then you see, look on the right here, you're going to get used to seeing these symbols as you move through Visual Studio and C#. The number and the owner and the balance, you can see their types and their names, and that's kind of a nice view of what's going on. All right, let's go back over here and see what's going on. We've got our members and our properties and our methods. To open a new account, we need to make one. We need to construct a bank account.
Right. So far we've designed what a bank account should look like and different properties it should have, but we haven't actually made one.
Right. So if someone were going to make a bank account, they would have to go and say, bank account, let's call it a constructor. Now I could make a constructor that doesn't really do anything, but you can't open a bank account with nothing.
Yeah, like you at least need a number, right?
You
That's
need
one
a
of the
name,
requirements.
You need an amount, exactly.
And since the number doesn't have a setter, we should probably create it at the constructor.
Yeah, so then let me think here. We got what? We have the name of the person.
Yeah, that'll be one of the input things.
Okay, and then we were doing data types before, integers and longs, decimals. What is the right number for a bank account? I mean, I have pennies, but I also have fractions of pennies. It's not an int.
So we declared the number up at the top as a string, right?
No, that's the number. That's a great point, actually. This number is the bank account number, which might have letters in it. So it's actually a string. But the balance is a decimal. So why don't we make the initial balance
that's right.
a decimal as well?
Because you need to have cents. So it needs to have two decimal places. You have to have
cents or whatever your fractional currency is.
Right.
Okay, so here's where it gets interesting. Those are arguments. How do I get those into these properties, right? I basically need to tell it about this object that I'm in, this object, the one that I'm working on.
Right. So the parameters are being input into the constructor, but nothing's actually been assigned.
Right. And this is where I think object-oriented programming gets confusing to people, because this is a description of what a bank account could be like, but it isn't a bank account. It's like a template for a bank account or a description of a bank account.
Or like a form. Like we require all of these things, but we haven't filled out the form yet.
It is a form that we're filling out. That's a great way to look at it. So these are the form fields, and I need to make sure that this information in the constructor, when I make the form for the first time, goes into the form fields of whatever this current account that we're on is.
Yeah.
So I'll say this. The owner of this account will be the name that we just passed in, and then this balance will be the initial balance. And after I've done that, that goes away. And that's really it's thrown away because I copied it into here. Does that make sense?
Yeah.
But look at this. It says you don't even need to say this. I like to say this because it means this object, not that object.
Okay.
But they're saying it doesn't really matter. It's kind of like var. It's one of those things where if you like the way it looks, use it. And if you don't, that's cool too.
Cool.
Okay. That's not the awesomest bank account, but at least I could make it and test it. So how would we do that? What would be the bank account hello world?
Yeah, how do we call this? So now that we have an object, when we have the template for it and everything, we need to actually input data. So let's call this, how about in our program?
Okay, so back over in
.cs.
hello world.
Yeah, and we can initialize, remember main is like the main entry point for any application. So we can, when we run this application, we'll just create one bank account. That's
Okay.
the goal.
So var account.
Real quick, does anybody see something that he has? I mean, they're going to cover it in a second, but something he has neglected to do that's going to cause his program to not work here in just a minute. Look at line 2. What's he need to do?
Doesn't he need to use like using bank account?
Yeah, excellent. Yeah, using bank account. He needs to import that namespace so he has access to all the cool stuff that he just did, right? So they'll cover that here in a second, but I just wanted to see if you were noticing that.
Yeah.
Equals, and then we knew something. And we've never done this before, have we? Because we've
No, we
always been
haven't.
saying like 0.
Yeah.
We've
something
never
like that.
knew something. Some people call it like newing it up, like as if newing is a verb.
Interesting.
Yeah, you ever heard that? You ever new up
New
something?
it up.
So let's new up
I'll have to
a
use that.
bank account. And then when we pass in, we'll say Kendra's money. And look at that. It actually gave you the shape
Oh.
of that. It gave you the help. And if I hit comma,
Because we're calling the constructor right
Yeah,
now
look.
that we just defined as needing the parameters of a string and a decimal.
right. And that's why you use a Visual Studio. If I use Notepad, I could do this, but I wouldn't get all of this help. I wouldn't get all the
hints.
spell checking, right?
Yeah.
So Kendra has $1,000.
Maybe just
Nice.
add a few zeros to that.
Congratulations,
That'd be
$10,000.
excellent.
Really nicely done. And then let's do a console.writeLine, just like before, except this hello world would be different. This is the hello bank account world, isn't
Right.
it? So let's go and do our string. And I'm going to put that string interpolation thing there, right? That's important.
Yeah.
So we'll say account, and then something was created for Kendra with some money. Okay, so let's go and get or dig our information out of our object there. So what is it? Account dot account dot. See how I didn't get my IntelliSense unless I spelled it right.
Right.
So account number was created for account owner with account balance. Ooh, that's cool. Does that look like a decent banking hello world?
Yeah, I think we
All right.
can call that.
Let's give that a try and see what happens. Ah, look at
Account
that.
blank.
Account blank was created for Kendra with $10,000. So in the next video, we're going to figure out what a good account number would be, how to make one, because we're going to have lots of different accounts, and we never even figured that part out. We only did names
Right.
and balances. So that's just us defining an object and making an object.
Now, I know you're probably thinking, hold on a second, they didn't do the thing you said they were going to do. Bear with me, they will. Anybody want to, while I'm loading this next one up, want to wager a guess as to why? I'm not going to tell you if you're correct or not, but does anybody want to wager a guess as to why he didn't need to do the using bank account? Yes.
Because it's smart.
Yeah, that probably has something to do with it. That probably has something to do with it. But you'll see here in just a minute, and we'll discuss that. That's funny.
Hi, we're learning C# 101. We've been making a little bank. We're making our tiny bank, and we're using object-oriented programming. So far, our tiny bank doesn't do a lot, I'm afraid. Right now, it just prints out the account number for an owner and the balance. And actually, when we tried to print out the account number, we didn't even get that far.
Oh no,
Yeah,
it just
so
has a blank where
account
account
blank.
was something.
Right. So let's go figure out what's going on there. So account number is a string, and we never really did anything with it.
Yeah, we didn't set that string.
Right. We didn't initialize or start up that account number, and we're following this tutorial up on the Microsoft Docs, and they're suggesting a way to go and do 10-digit numbers by seeding it or starting it with an initial number. And there's lots of ways to do this. So if you're a super advanced person who's watching this 101 video, you might want to ask yourself why you're doing that. But you might also want to understand that there's a lot of complexity. We aren't making an actual bank. We're making a fun simulated bank. So,
Right.
so do bear with us. But what we're going to do is we're going to have this account number seed, but it's private. We don't want anyone to know about that, right?
Right.
It's private in that people won't be able to see it outside of the bank account, right?
Right. So this is only going to be used inside this class and
It's
not
internal.
external.
It's like it's an internal thing, exactly. It's an integer, and it's static, which means it's being shared across all of our different instances of bank accounts. So every bank account has the same seed.
Okay.
So we'll see if that's a good thing or not. There's lots of ways to potentially solve this problem. But the idea would be in the constructor of this bank account, we're going to go and set the bank account number to that seed, and then we're going to increment it so that the next bank account has a different bank account number. Again, not perfect, not the idealized way to do this, but for the purposes of our little single instance, single threaded thing, this will work great. Each new account gets a different account number. Does that make sense?
Yeah.
So do you think that'll work? We put that, turn it into a string. Notice that we say int toString, and we store it in here because, you know, sometimes account numbers have letters in them.
Right.
There we go.
Yay! Now I have an account number
Now
for
you
my
have money.
bank account.
Okay. It's not a very intuitive number, I'm afraid, the simplest possible number, but the next one would be 91 or 92.
Right.
Okay. Cool. So here's where it gets interesting. They're suggesting that in order to create deposits and withdrawals, we need a history of transactions.
Ooh.
So we should really make another class.
Right, for all those major purchases I've been making. Okay.
Do you like to have one file per class when you make your programs?
I do. I
Okay.
tend to try to do that, unless that class is only being used by the class that shares its file. It's just, again, all of this is organizational preferences.
So you don't have to have all these things in different files, right? Just like if you wrote the Great American Novel, you could have the entire thing in one Word file.
Ooh,
Or,
risky.
or you know, every paragraph could get its own Word doc, which would also be weird.
Ooh, cumbersome.
And
Yeah.
exactly. The same thing applies with programming. So you get to decide, but I think a good rule of thumb is each class can get its own thing. So we'll say transaction. Cool. And I'm going to copy that one
Yeah,
to
it's kind of long.
save a little time. And we'll notice that that one's public as well. It's got, let me think, every transaction has an amount and a date and some notes about the transaction. And this is a real common pattern, isn't it? This constructor where you pass things in and then you basically plug them in. You're passing them left hand, right hand, left hand, right
Yeah,
hand.
so you set all of your properties.
Okay. Now I've got a transaction and I've got a bank account, but I mean, they don't really know about each other. There's no list of transaction managed there. I'm not sure what we should do.
How are they supposed to interact? So I guess I'd assume that one bank account has many different transactions associated with it.
That's fair. And we've been talking about lists of stuff. We did lists of strings and lists of ints, but we never really made a list of a type of our own making.
Right. So should we make a list of transactions?
Let us
here?
do that. So let's make it private for now. We could decide later maybe if we'll make it public or not, but I'll say list of transaction. Look at that. And then we'll just have it be like maybe all the transactions, all transactions. And then this is really interesting. If we just did that, do we really have a list there? Or do we just have a null or a nothing list? We have the box or the space set aside for a list in the future. But we don't really have a list, you see?
Right, because it hasn't been, I guess the space hasn't been found for it.
Yeah.
Like the variable name is claimed.
Yeah, very well
So you
said.
can't reuse all transactions, but they're adding the new.
That is a great way to put it.
Yeah.
We blocked out we put our thumb on the chess piece and said, that's my name, all transactions. I'll make one of those later of some size. Now here, we've got an empty list of transactions. That's a little bit different. And that is working just fine because we already have a system.collections.generic at the top there. So if I had a list of transactions, do I keep a running balance or do I calculate that balance from my list of transactions?
I think you'd want to keep a running balance. What are you thinking?
Well, so right now we've been keeping it in a place called balance, which has been the kind of the initial balance, right?
Right.
But you're right, like it does make more sense that every time someone asks for the balance, we need to check, right?
Yeah.
So this looks and feels like a decimal property, but we can calculate it, can't we? We can go like this, and that getter becomes a bit of behavior. It becomes a function of sorts, doesn't it? So I can go and get the balance. So let's see what we could do. We could start with an initial balance of 0. So let's assume that everyone starts with $0. That seems fair. And then remember our friend the for each. I love this. And I just did a, look at that, I love that. For each tab. For all the transactions, because it's a list, I get that for free. Balance. Now remember before we did balance equals balance plus item dot whatever.
Right. Is there an easier way to write all that out?
Yeah, I found out that you can go like this. So balance equals balance plus item amount. The same thing like that.
So those two lines, that's the same statement basically?
Yeah, they are equivalent to each other. Balance equals itself plus. You're basically adding 2. And then of course you can guess that you can subtract as well.
Ooh.
These are what you mentioned this. This is why you like C# so much, right? It's syntactic sugar.
Yeah, and it's not that you needed to know what plus equals means immediately. You can kind of discover it and simplify your code as you go.
And you know, I tell you, you and I have both been doing C# for a very long time, and I discovered those things, I would probably say, every week or so.
Oh yeah, I'm always discovering new stuff.
And there's nothing wrong with that. I mean, they always say when you learn things like Go or chess, it's like a minute to learn, a lifetime to master.
Oh, sure.
I am learning new bits of fun syntactic sugar, or like, oh, but you could try like this and it looks more like a poem. Right?
Yes. We're always aiming for poem status with our code.
Yes, if it reads like a haiku, then you've done it correctly. So here in the balance, we go and we list all the transactions and we return it. And then now this balance can go away because the initial balance in this case was already 0. So initial balance can disappear because everybody starts with 0. And then we just need some transactions. So let's just see if that still runs. Uh-oh.
It looks like you got an error. So we're actually going to fix that. There's some object-oriented problems that we'll re-architect a bit in the next video.
Okay, so pretty basic stuff, right? I mean, we got over that concept before. There's that plus equals there again. Sort of like what we had in Python, but that's where it shows up in C#. Is to basically do my balance equals the current balance plus or minus something else, right? Okay. All right. Now we're gonna watch one real quick here on methods and exceptions. Then we've got one on exception handling. Does anyone have any questions, comments, concerns, thoughts, ideas thus far? Nope. Okay. Let's check out this next video.
So in our last video, we actually introduced an exception into our code. Let's take a closer look at that.
So I went and tried to compile, and I'm being told that bank account balance cannot be assigned to. It's read-only.
Right.
Yeah, I thought it was clever because I made balance a getter, but the initial balance, it won't let me set it.
Right. So now that we're actually thinking of this balance as something that's directly related to a transaction, we shouldn't actually just give people an initial balance. Like, we don't want to give away free money, right?
I see. The initial balance is the first transaction.
Right. So that should be a deposit.
Ah, okay, cool. Well, we never wrote deposit, though.
Yeah, why don't we go ahead and do that?
Okay, so this dot balance, initial balance, that's going to have to go away. And then we need to go and write how to make a deposit. And there was a list of rules about certain things, like I shouldn't be able to deposit negative money,
Right.
stuff like that. So let's go back and look at our instructions here. And they've given us that code. So to save time, I'll copy that, and then we can walk through it if that's okay.
Sounds good.
So all I'm doing is I'm selecting make deposit and make withdrawal and copying over the top of them. Now it might look like a lot of code, but let's just zoom out just a smidge and let's figure this out, because this actually is cool because it puts all the things we've learned together, right?
Right.
Ifs and lists and all this stuff. So what's going on here?
I do see something a little new.
Yeah, so
Those
hang
are
on.
those exceptions?
Yeah, so
oh, okay. We'll
if
get
amount,
to that.
well, if amount is less than 0,
Uh-huh.
right? If I try to deposit negative dollars, what's a throw? That's totally new. So throw new argument. We know what arguments are. These are arguments. Out of range exception. That's exceptional.
Yeah. So it looks like it's checking to make sure that the amount needs to be, above 0, or at least equal. Yeah, above 0.
I guess you could deposit 0. That's kind of weird, but then we could figure that out
I
during
don't think we should bother with
during
it.
our code review. So
Let's do at least some amount of money.
so if it's less than 0, then it's negative, and we throw an exception. And an exception is a big deal, right? It's exceptional. It stops the program
Right.
if you don't catch it and look at it.
Mm-hmm.
If I tried to go to a real bank, and actually, this is a good question for you. As an object-oriented programmer, I go and try to model reality. If I were to go and cash a check for negative dollars or deposit a check for negative dollars, wouldn't that kick off some kind of business process at the bank where they would be like,
Probably. Like decline, do we owe you money? Why don't we just write you a check? Why do you need a negative check? Checks don't work that way.
questions will be asked.
Yeah.
So that's an exceptional moment.
Yes.
And that is what an exception should do. You throw exceptions when something's completely out there. This is an interesting one down here in make withdrawal. Like, what if the balance that you have minus the amount you want to withdraw would make your number of your balance go
Ooh.
under 0?
So that's an overdraft.
Right. That's an
Not
interesting
good.
one. That's not an argument out of range. That is, in fact, an invalid operation. You can't take that money.
Right.
And then look, if you throw that, does it let you continue? Does the next line run? It does not. They'll stop everything. When an exception occurs, it's like, and this function is over. All
right.
things stop running at this point.
So we don't simply exit the if statement, because that's sort of what it looks like. But since that throw is there, it'll actually exit the program and not try to.
Exactly. It'll exit the function unless we caught it higher up, and then worst case scenario, it'll go all the way up and exit the entire program. But the intention is that it'll exactly stop the running of this particular method. So if we look at these without the ifs, it looks very simple. Make deposit, new transaction. Add a deposit. Make withdrawal, new transaction. Negative amount,
Yeah.
add a withdrawal. And then you add the guards around it, and it becomes a little bit more kind of fleshed out, a little bit more.
Yeah. Maybe more secure and enforcing the kind of pattern that we want people to use with the system.
Exactly. So then the question is, what would bank accounts constructor, remember before I was just shoving the balance in there directly, what would that look like in this new world where I have a deposit?
Right. Well, instead of just assigning the balance to a static number, we should actually probably review all transactions to see what the balance is.
Right. So we've done that here where we say for each item, and that's a balance. We started at 0. That means that an initial balance rather, should be itself a deposit.
Ah.
So I will make a deposit of the initial balance. We'll start it today. This is kind of cool. We haven't done
Oh
dates
yeah,
yet.
I like that it needs a
time.
date. That
Yeah.
makes sense.
Well, you can say datetime.now,
Ooh.
right? And then no one passed in a memo, so I'm just going to say initial balance, starting balance. So then I would think we call make deposit. It's going to add a new transaction to the list, and then we would expect that your balance would be, what did we give you, $10,000?
Yeah, so I'm going to lose that probably. Or I
Right.
could deposit that in the bank account.
Right, but see, look, when you construct the bank account, that 10,000, here's our constructor. the deposit of the initial balance is 10,000. So you should not lose that.
Okay.
Then when we check
Well,
the
I have
result,
to give it to the bank.
Oh, you
is
do have
what
to
I'm
give-
saying.
yeah,
The
you
bank's
do.
not giving it to me anymore.
no, that's a good point. No free money in our
Dang
in our
it.
tiny bank. There we go. Look, so now we're back where we were, but it's more object oriented, and that's really interesting. So then now we can start simulating our bank. Okay, so let's do this. Let's take a little bit of money out and just see what the difference is. So what? Account dot make withdrawal. What do you want to buy?
Ooh, let's buy like a hammock.
How much does a hammock cost? $120.
Yeah, that's like a good hammock
It's a high
on
quality,
Amazon. It's
fancy
good.
hammock. Okay, datetime.now, hammock. Okay, and then we're going to go in console.writeLine, account.balance. Remember that balance is calculated from our list of transactions. Let's see if this works.
Right.
Look at that.
There we go. So my withdrawal was calculated, and now it's output as my balance, which is now $120 less than what I had.
Absolutely. So let's take a little bit of a break here, and then we'll come back and let's actually print out the entire ledger and like make it look like a real checkbook or a real bank account.
Like for all my transactions.
All your transactions.
All right.
Let's do it.
Pretty cool. Has anyone raise your hand if you are familiar with the term illegal operation as it refers to computers? Has anybody ever heard that or experienced that? Okay. So an exception. What is an exception? Let's start with that. So anyone want to give me a definition of the word exception in that context?
So basically, like an exception is basically something that, for example, like an exception handler is looking for a specific type of data or something, and if it doesn't fit those, standards or whatever, it says, hey, like,
Yeah, absolutely. Yeah, excellent. Another way you might say it is that an exception is a scenario when you are asking the program to do something it either literally cannot do, like divide by 0, or something that you have told it you don't want it to be able to do, like withdraw more money than you have available in the bank, right? Now, this is a little beyond this, but it's more computer science-y than like programming, but these aren't exactly the same, but think about it like this. So at the program level, we call things like that exceptions. On the operating system level, we call them illegal operations, because it's an operation that the operating system cannot perform. At the kernel level, does anybody know what we call that? So like a blue screen of death. Do anybody know what we call that at the kernel level? It's called a kernel panic. And basically, that's a scenario. Anytime you get a blue screen, if you take out a game, like if you're playing a DS and you take the game out as you're playing, it gives you a pink screen. It's a kernel panic. So anyway, it's basically just a scenario when you are either, to reiterate, asking it to do something that it functionally is unable to do. So like in the case of the DS, it's trying to read a game that doesn't exist, right? It's like trying to access things in memory that are no longer there. In the case of the bank, you're trying to withdraw money you don't have, right? So something that it either cannot do or something that you have asked it not to be able to do. Okay. All right. Let's watch this one final video here. I hope that everyone has been following along in Visual Studio because I'm going to ask you to do this exact thing that we've been watching. So if you've been following along, you are already one step ahead.
In our last video, we basically completed our app. We have transactions, withdrawals, deposits, all of that. So let's throw in a few things that it's not expecting.
Okay, so right now we bought you a hammock. So let's go and maybe make a deposit of -$300 because you can't deposit negative money, right?
Right, so this shouldn't be able to work.
I'm pretty sure this would be a bad thing. Stealing, I don't know what we call that.
Oh my goodness.
Yeah. Let's see what happens if we do that.
And what did you use to run it again?
I've been pressing Control F5. Now this is a great point that you bring up. You can always push this button, but that button starts a debug session, and we talked briefly about debugging. And if I don't want to run the debugger, I can just say start without debugging. So it's been a habit of mine to press Control F5.
Gotcha.
F5 for debugging, Control F5 to not. Either one works, whatever makes you happy.
And what happened? Oh my goodness.
Okay.
So
Amount of deposit must be positive. Parameter amount. So it's telling me a lot of information. It's even telling me the line number. Look at that. Bank account line 44. Let's have a look at that. And here's a pro tip. You taught me this. Control G.
jump to line number 44.
44. Wah,
Boom.
wah. Look at that. So it did not make it there because can't put in negative money. Not cool. Amount of deposit must be positive. So that's cool. Now it stopped the program. Like it's done. We're not banking anymore. So that's problematic.
Right.
So at this point, what can we do about that? Well, we could possibly catch that, and we can go back over here and learn about this. If I wanted to go and grab some code, I'm going to take this code from our document that we're doing. We're in here in the Exploring Object-Oriented Programming, right? So I'm going to copy that little chunk of code there and put it here. We'll go ahead and copy overstealing. There we go. So we're going to make a bank account with negative money, and then we can actually try. This is like, we're going to try. I mean, it could work, right? You never know.
Right. So it's a way of sort of testing your code, and then if something doesn't work out, we do actually catch the exceptions and print them to the console.
Exactly. Now, we do acknowledge that this is not testing. I mean, it's technically testing, but as someone who like owns testing
I
for
mean,
Visual
there
Studio,
are better ways to test.
and we will
just
show
gonna
those
say.
better ways in videos later on. So bear with us. We will show you some great fun ways to test.
But this is good when you're just trying to figure out what will break, if
Right.
it breaks at the right time, all of that.
But a good thing to test is at the later on, I'm going to go and maybe do another withdrawal of $50 for an Xbox game,
Ooh.
and then output the balance. If this really stopped, then I would never get my Xbox game,
Right.
right? And if this shut us down, if this was such a major bug, but if it's simply something that was a guard, it's almost like when you're bowling. This is the little things that keep me from going in the gutter.
Oh yeah, like a guardrail. Okay.
Exactly. So exceptions as guardrails. Okay. So there's your initial $10,000.
Yeah.
There's your hammock. Here's it preventing me from making a new account with negative money. And there's the balance after my Xbox games.
purchase. Yeah.
Okay? So the exception, if you catch it, like you're throwing yourself on the grenade, you did not actually blow up your entire program. So
Right.
that's kind of cool.
So it's sort of a way of, it'll still give you feedback. So you can still write in your catch statement like console.out line and
Exactly.
figure out what exception message to outprint, but it lets you continue with the program.
Exactly. So we'll take that and I'll put that elsewhere for now. I'll just move that down a little bit. And they've given us another one too to check for negative balances. So I've got a couple of fun things where I could take out like $75,000. These are tests, and they're only tests because I put a little comment there. We haven't seen comments yet. But if I go / hey, this is a comment. Next couple of videos, a little later on, we'll go and test those for real. But you know what I'm realizing as I was trying to figure out what was happening in our app? Did you notice that I was like, that's an Xbox game. Trust
Yeah.
me. This is a hammock.
Yeah, it's a little unclear what transactions were happening.
This is not pretty at all. I think we need to go and log all of our transactions. So why don't we do that, okay? So let's walk through that. At the end of buying the hammock and the Xbox game, I'm just going to make some space. White space doesn't matter, right?
Right.
I could go and spin through that stuff here, but from an object-oriented perspective, whose responsibility is it to give me the account history?
Ooh, probably the account itself.
Well, and that's a good question, right? Like, yes, but it depends. And this is where you, the reader, could decide, well, I don't know. Like if I go to a library and get a book, does the library check out the book? Or does the book check out itself? I don't know.
How automated is your library?
There are consultants that make their money answering those questions. Maybe you one day can be one of those consultants, people who are watching. I know that arguments can be made in both ways, can't they?
Definitely.
So let's do this. Let's do what you said, And let's make the bank account in charge of that.
Yes. Okay.
Awesome, you're winning.
So we need to print out some kind of transaction history
Okay,
thing.
so let's make a thing. Notice, of course, we talked about void is does nothing. Our function is going to return a string that's going to describe
Okay.
what's
So
going
we
on.
can just output that string to the console.
Yeah,
And
'cause
that'll be our
We
account
live in
history.
console world right now.
Sounds good.
Okay, so get account history. I assume it's for this account, so we don't need to like have any parameters, right? It's the account that we're currently working with, this account.
Yeah, it'll be like the list of transactions with this specific
Mhm.
account.
Now, a lot of times we've been doing strings like this, where I say $ whatever, but someone told me that if you make lots and lots and lots of strings, that there's a better way to do that. And that's called a
Yeah.
string builder. So we're going to make a report. Let's do this report. And then where is string builder located? If I say new string builder,
Will it find it?
did it find string builder automatically? Is that Visual Studio found? Oh, it's in system.txt.
Oh,
So
okay.
it was already there.
So we have the namespace imported. Cool.
That's cool. All right. And then we'll say report. And this is interesting. String builder for building strings. It has like append line. We'll add a line. And then it takes strings. So what do we want to put in there? What do you think?
How about the date, the amount, and the note?
Okay, so let's go date, amount, and then the note. Those are kind of the properties, the characteristics. And this is a fun trick. You could like do it like this, right? Like I could
Right.
go like space,
You
space,
can
space,
just
space,
add a
space,
bunch
space.
of white space in
Yeah.
between to sort of make it like a column.
Yeah, or I could do this. That's a tab.
Ah.
Isn't that funny?
Yeah, so this will make our columns a little bit more evenly spaced,
Yeah,
right?
exactly. I think amount has one M.
I like it.
Excellent. So, lots of different ways to do this. And then our friend, the for each. So for each item, where did we put our transactions?
I think they were in an all transactions
Okay.
list of
Yep.
type
That was right.
transaction. Okay.
Cool. So for each item, or in this case, each transaction,
Mm-hmm.
then the report's going to need a new line, I think.
Right, so this will be like the first row in the table that we're outputting,
Yeah.
right?
Okay. Yeah. So we're
So
making a
date,
table.
amount, and notes were sort of the header of the table.
Let's put a comment there. Header. Good idea.
Okay.
Okay.
And these will be
report
rows.
Rows. Here we go. Report rows. Cool rows. Oop. All right. Now this would be a place to maybe do some of that string fun with the $ there. So what do we have? We have an item, which is a transaction.
Mhm.
Now this is
So the
interesting.
first one was date.
Date. And let's say, well, I think we had a tab because we'll have a tab for these as well.
Makes sense to separate each of them. And the next one we wanted was the amount,
Yep. Amount. Okay. And then a tab.
and then any notes that they had on that transaction.
Okay. Item. That's like Xbox game or whatever.
Yeah, I think the only one we added so far was the deposit.
Mhm.
Cool.
Okay, cool. And then let's return that string builder, and I think we put string builder in report. So return report. Remember our method returns a string? It's a report, but hey, we made a string builder,
Oh, not a string.
not a string. How do we get a string out of there?
Oh, it looks like there's a toString method
Yeah,
on the string builder type. So we
turns
can
out
call that.
everything in C# has a toString. So no matter
That's
what
very
you're
common.
doing, you can get a toString 99% of the time or more. So there's our toString. I don't know if this is going to work perfectly because I don't know about that date. I haven't said how that date's going to look, but let's go and see what that's going to look like. So back over here, let's go and say console.writeLine account dot, and then where's our get account history?
There we go.
Aha, now we're talking. And then I'm going to put that inside of a function because that's a method within WriteLine. All right, and that's good.
So that single right line should output a whole table.
If we did it right, I think we should get a nice table.
Cool.
If we did it wrong, we should just stop recording now and just give up and quit our jobs.
Let's try it out.
All right, crossing fingers.
Okay.
Okay.
So it looks like it
So-
has a date.
It's a little bit shifted off to the side.
Yeah. Maybe we should add more tabs.
Well, there's a couple ways we can do that because I don't know if I need all that detail. Like I've
Right.
got dates and stuff. I'm also going to comment out these exceptions because they are stressing me out. So what I'm going to do is I'm going to get rid of these balances, just for cleanliness' sake.
Sounds good.
I'm going to go down here, and then I'm going to do a trick that you showed me as well.
Oh, comment
you
out
go-
the entire
yeah.
block.
You know it, right? You know what's up.
Control K, Control C, I
Yeah,
think.
so you know the exact.
But it's also in the.
There it is.
There you
Control K,
go.
Control C, boom. That way we don't.
Boom.
So we've commented it. We keep our code. We'll just worry about it in another video. Okay,
Nice.
so check this out. I'm going to get back over to get account history. I could click there, or I could right click, go to definition. Love it. Okay, remember that date? I can hit dot. There's other ways to express that. Remember how we said everything has a toString? Well,
Yeah.
dates have like toShort date string or toShort time or whatever. So depending on what language you speak and where you are located in the world, that might come out in Russian or in French or whatever,
Oh, right.
the way that you want it, and you want that to be specific to your location. So I just said, let's do that date as a short date string. Let's see if that makes it better. Look at that.
Nice looking.
Huh?
Oh,
Only
that's
thing we
great.
could do to make it better would be put like a $sign or a British pound or whatever that we're doing. But I think
Right.
that's pretty sweet, and we have achieved object orientation at our tiny bank.
I love it.
So hopefully you have enjoyed playing with this as well. If you have gotten stuck at all, you can go ahead and look at the source for the tutorial in the GitHub repo. We'll make sure to include links for that in the descriptions, and you can find all of that at docs.microsoft.com. This is the end of the C# 101.
Okay, so before we go any further, man, he didn't use the using bank account like we talked about. Any thoughts as to why he didn't? I intentionally led you in that direction to see if you then had that question and had a thought as to why that might be the case.
Because like they're all in the same folder.
Yeah, specifically, they're all in the same namespace, right? Whenever they made the new program, right, My Superbank or whatever it is that it's called, that's the namespace that it's located in. Now, you could further, so the idea behind multiple namespaces would be if I have things that are either wholly unrelated or loosely related to one another, right? So, which is to say, wholly unrelated, I don't need to import them, right? Because they're not going to talk to each other, it doesn't matter. Loosely related might be like, oh, there's a thing here, I need to be able to access this thing over here on occasion. Then you would want to import that new name. You'd want to put it under its own namespace and import it, right? So if you had like a database of citizens in like a town, let's say, and you wanted to be very inclusive about that, you might have a namespace called people. You also might have a namespace called pets. You also might have a namespace called businesses. You might have a namespace called schools and that kind of stuff, right? And then within those, you know, the people class would probably want to be able to talk to all of those, but the pets class probably would need to be able to talk to the business's namespace, and does that all make sense? Okay, awesome. There was one other thing. Oh, they said add a $sign. Do you remember how to do that? As soon as I say this, I'm going to be wrong. It's an uppercase D, I believe. An uppercase D. I'm next to certain. A lowercase d does something else, because the lowercase f is for float. I think it's an uppercase D. I'm next to certain. We'll format it as a decimal number, a floating point decimal number with a $sign in front of it. I'll during the break I'll look into that to double check, because I want to say it's a capital D, but as soon as I say that I'm going to be wrong. Okay, so if you were following along, whenever we come back from break, we're going to have a little short in-class quiz thingy review thing like we had last time, and then you'll get to work on this little bank program. If you were working on the bank program during the videos and whatnot, after we're done with our review, if you're an adult student, you're obviously welcome to go, or you can stay here and continue to work on other stuff. Are there any questions, concerns, comments, thoughts, or ideas? No? All right, come back at 10 after, and we will do our